So we spent a lot of time looking at contrapositive right here. Well, what about the converse and the inverse? Well, if you recall, I made a note that said that the converse and the inverse, so that is Q implies P and not P implies not Q, those are not logically equivalent to P implies Q. And it's pretty easy to prove that claim that these right here are not logically equivalent to P implies Q. And we can actually do that via a truth table rather simply. So if we had P, Q, P implies Q, and then the converse and the inverse, I don't have to fill out this entire truth table. To be able to show that this expression right here is not logically equivalent to either of these expressions right here, all I need to do is find one particular truth value for P and one particular truth value for Q that makes these rows differ. So, in fact, if I make P true and Q false right here, let's go ahead and see what we get. Great. So the only time this implication right here, P implies Q, is false is when the hypothesis is true and the conclusion is false. Well, here the hypothesis is true and the conclusion is false, so I know this thing is false right here. However, over here, the hypothesis is false and the conclusion is true. That's perfectly fine. So that is true. And then over here, for the inverse, well, I have not P, so I have a false, implies not Q, a true. So this is false implies true. That's perfectly fine. That is true. So there we go. I have one row in my truth table where P implies Q differs from either its converse or its inverse. Therefore, neither the converse nor the inverse are logically equivalent to P implies Q, or the original statement right here. However, what about the relationship between the actual converse and the inverse? Well, it actually turns out that the converse and the inverse are logically equivalent to each other. So here, I'm going to make the following claim. So I claim that the converse is logically equivalent to the inverse. So that's my claim. And then the proof of this actually follows almost identically to the proof of showing that the original statement P implies Q is logically equivalent to its contrapositive. And so all I need to do is start writing down some definitions. So the proof of this is as follows. So I'm going to use my definition of implication right here. So again, what I'm going to do is negate the hypothesis, and then I leave my conclusion right there. Then I'm going to take this second statement right here and do the same thing. So here again, I'm going to negate my hypothesis, and then I leave my conclusion the same, and I get that. And both of these right here are by definition. But then I see I can apply some of my identities to simplify this thing. So here, this double negation right here, I get P or not Q. So that right there was a double negation. And then again, because of commutativity, I can write that this thing is logically equivalent to not Q or P. So therefore, what I have is Q implies P is logically equivalent to not Q or P, which is itself logically equivalent to not P implies not Q right here. So it turns out that the converse and the inverse are logically equivalent. And beyond that, actually, if you really start to understand the definitions of contrapositive, converse, and inverse, you might have noticed the following. Let's go ahead and on the side, consider this. Let's pretend that our original statement was Q implies P. Now, what happens if I wanted to apply the contrapositive to that statement right there? Well, what the contrapositive says is I should flip the P and Q and then put knots in. So I should flip the hypothesis and conclusion and then put knots in. So here, I'm going to flip the hypothesis and the conclusion. So I'm going to flip the hypothesis and the conclusion, and then I'm going to put knots in right here. So if this was my original statement, this right here is the contrapositive of my original statement. And you'll notice that that right there, that's nothing but the inverse. These guys right here are logically equivalent. So if you want it to sound super fancy, you could write the inverse is the contrapositive of the converse, and so is logically equivalent. So the inverse is the contrapositive of the converse, and so is logically equivalent right here. So to summarize, we have the following. If our original statement is P implies Q, then its contrapositive is not Q implies not P. So this here, I'm going to call my original statement. The second one right here is the contrapositive. And then I had my converse, and I had my inverse. And so what we have is that the original statement and the contrapositive right here, these are logically equivalent, and I have these, the converse and the inverse, are logically equivalent, and anything on this side is not logically equivalent to anything on this side. And it's actually very important to understand the relationship between the original statement, the contrapositive, the converse, and the inverse once it comes to actually trying to prove things and prove things about algorithms.